for joining. Sorry. And today I'll be taking a smaller 1 hour session on AI in cybersecurity with IoT as security as a use case, right? So maybe a brief overview of what I'm going to talk about. For those of you who are not familiar with what IoT is, I'll give a very brief introduction on what is IoT, why is it important, why we should be discussing about IoT security in particular, right? What are the trends from IoT perspective? And then I'll delve deeper into the security requirements that we have from IoT side. What is so specific, what is so unique about the security requirements, in the context of IoT. And a very minor part of my session will be actually on the AI/ML techniques or challenges from an AI/ML perspective for IoT security, because throughout the rest of the presentation I try to motivate how the two connect, right? And also, if time permits, I'll try to touch upon what are potentially open good problems to work on from a research perspective in the IoT domain, right? Vis-a-vis security and AI and ML. So to begin with, maybe just to motivate, these are some very recent numbers for IoT devices that have been deployed in the market. And as you see, there are already few billion devices from IoT perspective deployed, across the globe. So as you see here, this is maybe the pointer is not there. Acha, it is there. Okay, sorry. Yes. So oops. Never mind, I can tell the numbers, right? So as you see here, the number of devices is already crossed 10 billion, right? And it's going to increase. And if you look at the increase, it's not a linear increase, it's going to increase exponentially as we go forward in time, right? So from a device perspective, it has already crossed the human population, by the way, right? So there are more IoT devices deployed on the planet than there are human beings on this earth. And very soon we'll have 2 times, maybe X times the number of population, right? So as a network itself, it's a very important network to analyze and to study, because there are going to be more and more nodes in this network, right? That is one. Another motivation is, please note, it's a very heterogeneous environment. Unlike the other use cases that we have been discussing as part of this course. For example, we were discussing phishing attacks, we were discussing malicious code injection attacks, or several other kind of attacks, right? Those type of attacks for certain ecosystems are very specific. You have, let's say, a smartphone environment, or you have a laptop, or you have a desktop, you have a Windows machine. A lot of things are homogenized in that environment. For example, the software is same. If you're using, so if we are talking about laptops, for example, and let's say majority of us are using either a Windows based or a Linux or a Mac based, right? So there are only 3 possible operating systems. This is not true in the context of IoT. In the context of IoT, everything can change across the deployments. So the hardware, there's a lot of heterogeneity. Use case itself, we can have different types of use cases. So we can have use cases like consumer IoT devices, you can have industrial IoT devices, we can have IoT devices in the context of healthcare, IoT devices in the context of smart homes. So there is a huge amount of variance in terms of what you are using the device for, the deployment scenario. There is also a significant amount of variance in the type of devices. So I might be using, let us pick an example, let's say surveillance, because security maybe has a good connotation. So from a surveillance perspective, we might be using video cameras, right? Now the kind of video cameras we're using in our campus, for example, vis-a-vis the kind of video camera we might be using in a home environment for home monitoring. There is significant amount of difference there in terms of requirements itself, right? The kind of requirement we have, for example, in campus, we have a lot of requirement for outdoor cameras. So they need to meet these requirements in terms of moisture, in terms of dust, right? There are these ratings available. I'm not sure how many of you are familiar, IPXX, there are those numbers, which essentially tell you in which environment you can deploy this device, right? So we have heterogeneity in the use case, we have heterogeneity in the deployment scenario, we also have heterogeneity in terms of the hardware. So for the same use case, for let's say surveillance, I can buy camera worth 2000 rupees. I can also buy a camera which is 50,000 plus, right? And the differentiating factor is the amount of features that they have, the amount of onboard computational complexity, or the type of options they're giving that the users can exercise. So there are some cameras which have built-in motion sensing. There are cameras with built-in face recognition. There are cameras with built-in human recognition, right? You can select zones and say, okay, if something moves in this zone, send me an alarm. So there is essentially so much variety in this ecosystem, and we're just talking about cameras, by the way. We can have smart meters, we can have vehicle tracking, we can have health bands. The list is almost endless, right? Which makes this ecosystem very important, because it is very challenging to have a single solution from an IoT security perspective. We have to figure out solution. We have to go down to the level of use case. In the use case, what kind of devices we are talking about. In those devices, what kind of platforms we are talking about. For example, now, even in the smart camera perspective, you can have cameras which are maybe running a version of Linux in the background, or maybe running a version of no operating system, maybe just a microcontroller, right? So we have so much plurality of devices, so much plurality of hardware and software in this ecosystem, that it's very important to understand that to create a solution, you need to narrow down your focus area from an IoT security perspective, right? One solution will not fit all, for sure, in the context of IoT security. And also, even from connectivity perspective, for example, you have this connectivity type here. As you see, there is cellular 5G IoT, wired IoT, right? So many different types of communication modules are available. So you may have exactly same identical devices, but maybe they're using a different communication interface. Maybe the cameras deployed in some cases are using Ethernet. They're powered by Ethernet. In other cases, they might be using Wi-Fi. That itself becomes a surface, right? Because at the end of the day, from a security perspective, it's all a question of what kind of attack surfaces we have, and it's also a function of what kind of communication interfaces we have available on the device. So same identical device deployed in two different scenarios. Maybe in one scenario, it is using better encrypted version of Wi-Fi. In another scenario, it is using a lower encrypted version of Wi-Fi. So the same device all of a sudden becomes more vulnerable based on how you deploy it, right? So given that as a context, please also note there has been significant growth in the amount of attacks in the context of IoT devices itself. For example, year on year between 22 to 23, there was a 400% increase as per the report on IoT targeted cyber attacks. That's a significant jump. Also, within this 400%, well, not within this 400%, within all the attacks that happened in that calendar year, more than 50% were targeted on manufacturing sector, which is very surprising, right? Because typically we would like to believe maybe consumer IoT devices would be the target focus and all, but no, a significant focus has been on manufacturing sector, right? So it's all the more important for us, including policymakers and all the stakeholders, to focus on IoT security, because this can have very long-lasting implications. I think just 2 days ago in this course itself, we were discussing that if you don't take care of security, somebody can switch off the power, somebody can switch off the water, somebody can switch off all the basic amenities. How are we controlling all those basic amenities? We are controlling them through some IoT devices. At the end of the day, there are sensors and actuators involved, right? And these sensors and actuators together form the ecosystem for IoT, which is going to be my next slide also, or maybe yes. So then from a country perspective, it's strategically very important to have a policy in the context of IoT security, because these devices are going to be deployed in all sorts of cases, including non-civilian cases also. For strategic use cases, for example, police is deploying so many cameras. We are in Hyderabad, right? Hyderabad has one of the largest density of traffic cameras deployed by police, right? How do we make sure those feeds remain private? How do we make sure that data is not being used by non-state actors, right? So it's very important to make sure that the devices, IoT devices in particular, that are going into the network, meet certain requirements based on the use case, meet certain requirements from an IoT security perspective before we deploy them because post-deployment security is a very big challenge. For example, I'm not sure how many of you are aware, but there are these very cheap cameras that are available in the market, like very cheap might not be a good word, but okay, cheap cameras. There are these cheap cameras available in the market, like say 2,000, 3,000, 4,000 rupees, which once you deploy them, basically there is no update possible. They have some firmware installed and that firmware is there. If there's a vulnerability discovered in that firmware after deployment, pretty much nothing can be done. You just have to buy another camera. How many consumers or how many users have that kind of awareness? Or how many of them are even following, has a vulnerability been found in my device? And how many such manufacturers are sharing such vulnerabilities with the users? So vulnerability management is a big challenge. Unlike most of the other use cases we have seen so far, where our focus has been to detect the attack, to mitigate the attack, to figure out malware and all, in the context of IoT, the vulnerability part becomes very challenging because we have limited resources available. Please note, it can have very less computational complexity available on board, and that cannot be increased on the go. If I have deployed a camera, let's say for surveillance in a campus, I will not be changing that camera every year because that is like a capital expenditure, right? I can't be reinvesting in that system. So given such deployments, you have to make sure we plan for security a priori, not post deployment. Security should not be an afterthought. We should be designing the setup, we should be designing the system with security as a key feature in our mind, right? And that's why a lot of governments have now started focusing on IoT security standards. Some of them are already available. I'll be highlighting some of them as part of today's talk. Also, please note, device security is not ecosystem security in the context of IoT. Because in IoT, we are not just using the device. And maybe I will go to the next slide just to highlight that part. So for any IoT setup, it is a typical setup. You can have modifications in this, but of course there are heterogeneous versions available for this also. But effectively what we have some sort of sensors or actuators you can think of, which connect to an IoT gateway, which connects to, let's say, the cloud, and which connects to a mobile app. Going back to our example of a surveillance camera, we'll have an image sensor, a camera sensor, which will connect, let's say, through Wi-Fi to my IITH network, and then through IITH network connects to the internet, connects to the cloud, and then through the cloud I will be able to access it on my mobile phone, right? Now, please note, for this architecture itself, it's not that we need to make sure security only at the sensor, the actuator, or the device level. If the gateway fails, the whole ecosystem for IoT fails. If somehow somebody is able to get access to the cloud, that also ensures they have access to data, and maybe they have backdoor access to all sensors and actuators available at the device. If somebody is able to get access to the app, then also, for example, if you have a camera, most of the cameras come bundled with an app where you can use the app to change the focus of the camera. So if an attacker, maybe the camera is well protected, the device is well protected, but if somebody is able to hack into the app, they can indirectly change the focus. Maybe they can turn the camera around. Instead of focusing on the target area, the camera might be looking upward in the sky. That defeats the whole purpose of deployment, right? So now, from an IoT security perspective, we have to talk about security for this whole ecosystem, not just the device. Unlike some of the other use cases that we have been seeing so far in this course, where we have been focusing on maybe certain aspects, maybe let's say intrusion detection or malware detection or things like that. Here we have to talk about security as a whole, because if we do not focus on certain aspects from a security perspective, the ecosystem is going to fail, and if the ecosystem is going to fail, essentially the device will not remain secure. Which is why there are a lot of documents now available, both in the Indian as well as international context. For example, this is a document by TEC, which is, I believe, comes under Department of Telecommunication, Government of India, where they have proposed certain level of IoT classifications. And if you look at it, they have done a very detailed, good job in terms of figuring out what are various aspects from a security requirement perspective. And I think this maps well with the CIA thing we were discussing. So the correct CIA thing we were discussing yesterday. So they have features in terms of confidentiality, integrity, and availability, and also in terms of authentication or authorization. And for each of these features, there are multiple types of requirements. For example, for confidentiality, we need to make sure the message is encrypted. We need to make sure the device has some level of attack protection. It should have data encryption. Please note this is, and then we need to have some sort of tamper resistance in the device, some sort of assessment certificates, and a device ID, which can be both physical as well as logical. Now, what has been done in this document, which is very remarkable, is that we have looked at, can we classify devices, IoT devices, across different security levels? What do we mean by different security levels? So if it's an entry-level device, let's say a level 0 device, maybe it should meet only these 3 requirements. It should meet the requirement that there should be a feature of logging. It should log the data, or it should have some sort of ID, and it should have some sort of access control on who can use it. Right? It's a bare minimum for any IoT device. And as we move forward up the levels, as you see here, the ticks keeps on increasing. So for example, for level 1, it's a must to have a message encryption, some sort of data encryption, some sort of device ID, logging, secure firmware update and patch update, vulnerability management and response, user authentication, password management and access control, so on and so forth. So now as you move up the levels, the capability of the device keeps increasing, right? Another way to look at it is that level 0 device is a bare minimum device, does not meet much of requirements. So if you have any important use case, you should not be deploying any level 0 devices. What you should be deploying is bare minimum a level 1 device, which meets the baseline security requirements across the standards. In some sense, level 2 devices they meet the baseline security requirement, and on top of that, they added to security, cyber security based on international standards. Level 3 has that plus security by design in absence of any known common software vulnerabilities. Level 4 has all of that plus resistance against common cyber attacks, and they should be able to undergo penetration testing, right? So now, please note, from a level 3 or a level 4 device perspective, for example, a smart camera, I would like to say a smart camera deployed in a consumer home should at least be a level 2 device. Because if you're using anything less than level 2, we are putting our private data, at risk, or our home security at risk. Maybe level 3 also. But again, there is this trade-off, because there are going to be cameras which are going to be lower cost, which will meet maybe only L2 requirements. And then there are going to be cameras which can meet L3 requirements by adding secure booting and testing and adding secure policy update and response and all. So this trade-off is always going to exist. So we can have maybe L2, L3, even L1 cameras in the market. But what needs to be mandated is this sort of labeling. Right? This labeling should be there on all IoT devices so that consumers can make an aware choice. Currently, that awareness is missing, both from the consumer perspective and also from the device manufacturer perspective, because there is no mandate, at least in the Indian context yet, to force them to put such a labeling on devices. But ideally, it should be there so that anybody, or it can be like a stars, right? So you can have maybe a 5-star rating. 1 star means level 1, 2 star means level 2, so on and so forth. But at least that gives the consumer a faith that if I am buying, it is going to meet all these requirements. Right? So I think it's a very good step taken by DOT in that direction. They have also been working on some sort of ITSARs, which are Indian Telecom Security Assurance Requirements, which have looked at various aspects from an IoT security perspective. This includes topics like authentication, identity management, authorization and access control, storing sensitive information securely on the IoT device, making it easy for users to delete data on the device and in the ecosystem also, data protection in the whole ecosystem, including on the device, secure input and output handling, communicating security between the IoT device and the framework or the ecosystem, suitable cryptographic techniques, minimizing attack surfaces on the device. So one way to look at, for example, number 10, again, in interest of time, I'm not going into the details of each one of them, but all of them are very relevant and important from an IoT security perspective. I'll pick and choose 1 or 2 of them and just go a bit deeper, just to highlight, how different or how more elaborate IoT security is compared to conventional security when we look at it, right? So for example, minimize exposed attack surfaces. let's say you have an IoT device. At the end of the day, it can be bare minimum a microcontroller, right? A microcontroller with some sensors, some actuators, some communication module attached to it, right? One example could be, let's say, a smart meter. I can have a smart meter. This smart meter has a sensing device which is sensing the current. This smart meter has a communication device which, let's say, a 4G cellular modem attached to it, or a Wi-Fi modem attached to it, and some memory and some other features. Now, for this smart meter, if you look at the microcontroller, the board, when it is deployed on this PCB, there are going to be certain tags, or there are going to be certain interfaces which can be used for testing, because when it's being manufactured, we have to test the PCB also, whether it is working correctly or not, it's functional or not, is it meeting all the functional requirements or not. Now these, if we leave them open, they become an attack surface for an attacker, because you don't need any admin privileges to select any of those pins. So now we need to make sure that when we are shipping the device for the consumers facing device, we should not have any of such attack surfaces open. Let's say the device is supposed to have only Wi-Fi based connectivity, but for testing purposes there is a USB port available. This USB port either should be disabled or it should not be visible, right? We should physically cover it or something of that sort, because again, any communication port we are leaving open on the device which is not supposed to be there, which the user is not supposed to see or third party is not supposed to see, we are essentially opening up the device. It's becoming like an attack surface, an additional attack surface on the device, right? We should also have means to report and manage vulnerabilities. So vulnerability management is very important. It is slightly different from incident management, because vulnerability management is more from the perspective of pre-incident. There are these folks, let's say these ethical hackers, who are looking at devices or trying to find vulnerabilities in devices, and there should be a way for them to report these vulnerabilities to the manufacturer. Not only reporting, there should be a follow-up process also from the manufacturer. Let's say I report a vulnerability. I think this is one domain where we should probably acknowledge how commercial software companies have evolved. So for example, all these big ones like Google, Microsoft, they all have these bounty programs. So if you find a bug in their software and if you report it, they don't not acknowledge it, or they don't say no, there is nothing wrong with our software. They acknowledge it, and then they also reward in some sense. There is some monetary reward attached, if I'm not wrong. For every bug you find in their software, you get certain amount of dollars, right, based on the impact that particular bug has, which is a very good way to promote openness in the system by saying our software is not 100% foolproof, which is true for any software, by the way. We are open to feedback, and based on the feedback, based on the reporting of such vulnerabilities, we are going to revise, we are going to update the software. And which is why we keep on getting these updates, right? So a lot of these updates, if you check in your machines, whether it is Mac or Windows or Linux, a lot of these updates are security updates, because continuously people from the ethical hacking community, let us say, or broader community in general, are reporting these vulnerabilities, and then people are taking those vulnerabilities into account, figuring out solutions and patches to make sure those vulnerabilities are no more open in the devices already deployed. Now something same has to be done for IoT devices, right? So we need to have that openness in the system. We need to have a mechanism for vulnerability management. On the other hand, incident management is at the other end of the spectrum. Something has already happened. Somebody has already hacked. Let's say there was this news about some power system devices being hacked a couple of years ago. So post hacking, once we know such a system has been hacked in XYZ country in such location, what should we do about the systems we have deployed in our area of interest? So incident management is post incident. How does a company react? How does the organization react to their IoT device security vis-a-vis that particular incident, right? Again, please note, both of these require proactive support from the manufacturer, and not all of them may have the means to do this. Because it's easy to say, yes, we need all of this. We need supply chain, we need hardware security, we need firmware and bootloader security. But if it's a manufacturer who is basically manufacturing a low-end level 0 device, or maybe not even manufacturing, maybe they're buying the hardware from third party, just porting their software on it, porting their firmware on it, right, or packaging it together. So then expecting them to meet these requirements without a government mandate is very difficult. And that is where I think the policy part comes into picture. This has to be mandated by the government. Only then the manufacturers will start following it. I really doubt, because each of these points have a cost factor attached. For example, vulnerability management, it's easy to say, let's have a bounty program. Who is going to pay for it? Who is going to manage the program? You need additional resources, right? If you do not have one, you need to figure out some folks, some technical folks who can pursue these vulnerabilities which have been reported and then follow through, and make sure some patches are being developed by your core software team. So again, each of these aspects enhances security, but it comes at a cost. And I don't think any business is ready to invest additional cost unless forced to in some sense, especially from a consumer IoT facing device perspective, right? We also need to make sure that we have resilient built-in into system in terms of outages. We should be ensuring the software is updated in the device all the time. We also have to make sure software integrity is in place, plus firmware and bootloader security as well as hardware security, and then installation and maintenance of the device itself. That again has implications from security perspective. And lastly, the supply chain. I think the last one is something you will be appreciating a lot, because very recently there was this incident in West Asia where some of these pagers exploded, which effectively is a use case for security in supply chain, because the supply chain for those devices was not properly maintained, or at least not reviewed. So somehow somebody was able to supply pagers with explosives in it, right? And now imagine, and this was not an instantaneous event, by the way. Those pagers were deployed or supplied years ago, right? Now imagine, going back to the first slide, 10 billion devices already deployed. How do I know how many of those devices have and how many of those devices do not have an explosive in them? How do I check? So it's very important to make sure, especially for devices which are being deployed in a strategic fashion, we have to make sure for those devices we are meeting all these security requirements. Only then we can ensure an IoT security from the whole system perspective. If you leave any one of these out, it can have implications later. Now, as I was mentioning earlier, this is just a summary just to reiterate. So I was mentioning that we have the DOT document, right? So similar efforts are being followed across the globe. I'm just highlighting here one by Singapore, where they're looking at this labeling scheme, which is again very similar. As you see here, meets baseline requirement, give it 1 star. Adheres to principle of security by design, give it 2 star for any device. So now if you go to all devices being sold in the Singaporean market, every IoT device there has this star rating from security perspective, right? Which is a very good thing to have, and something we should also probably work on as we go forward. I think there is also similar effort happening in the US context as well as UK and Europe, but in interest of time, because I also have to go to the ML part, where ML fits in all of this, right? So, yes. So maybe in interest of time, I'm going to skip this part. Is the same thing reiterated? So it's the same thing. This thing also just a bit more detail on how each of these levels are different from each other, right? Maybe if you have time, if you're interested, we can discuss it offline after the session if required. So again, the same CIA metric that we have been seeing from the very beginning of this course. We have confidentiality, integrity, availability. It's a mapping from a class perspective. That basic level of confidentiality, basic level of integrity, basic level of availability. For class 1, we need to have medium level at least in integrity, availability. Similarly, class 4, we need to have all of them at high level, right? So on and so forth. So now, coming to the vulnerability reporting and management part, please note there are 3 types of vulnerability disclosure. There is private, there is public, and there is coordination required also from the manufacturer or the OEM side. From a cybersecurity framework perspective, please note we need to make sure that we identify what is the vulnerability. We protect our systems against those vulnerabilities. We have to detect them whether they're present in our current deployed systems or not. How do I respond to them? And how do I recover from those vulnerabilities if somebody is already exploiting them? Because maybe there is a vulnerability and I have reported it also, and there's a patch being developed. But what if already there are people exploiting this vulnerability? How can I minimize the damage? What is the message I can send to my consumers? So there is a lot of communication required between the device OEMs and the consumers using those devices to make sure there is security in the IoT framework. So we can have vulnerability disclosures which are private, where we privately share with the company. We should also have public vulnerability disclosures happening. But by private, I mean the company can directly tell only to the consumers whose device have such vulnerabilities, right? But then sometimes for public, an analogous example is you might have seen there are these articles or ads which come in newspaper sometime. XYZ motor company is recalling all cars with serial number this to this. Because they have tried to reach out to the consumers, but not all consumers respond. So we need to have some sort of public disclosure also that, okay, these are the kind of devices. Maybe these are the cameras. These cameras from this manufacturer of this year, please check. You need to ensure you mandatorily install this update, right? Something of that sort. Also, there has to be coordination across the domain, because a lot of times, let's say a camera is based on a microcontroller framework, let's say from another company, third-party company. I don't want to take names here, but so now, given this microcontroller framework is being shared across cameras, not just this manufacturer, multiple companies. If there's a vulnerability in the microcontroller framework itself, then that has to be coordinated across all, maybe not only cameras, maybe the same microcontroller is being used for smart meters also. So then we need to make sure there is a coordination happening between various entities in this ecosystem, that any discovered vulnerability in a particular platform is being shared across, right? So we need to mitigate the risk. So we need to make sure we are protecting our device security, which is one aspect from IoT security. We also have to protect the data, which is not necessarily device, right? It is slightly different. So we need to make sure the data is protected at the device, the data is protected in transit, and the data is protected in the cloud, or when the user is downloading it at the app. At all those levels, the data has to be protected. And then we have to make sure we are protecting the individual's privacy. Even though the data is not being shared with any random folks, but data is typically being shared with third party to enhance performance. For example, going back to our microcontroller example, if I have a camera, I'm a manufacturer, right? I have a camera which is based on a microcontroller platform from XYZ company to enhance the microcontroller's performance. A lot of times we share the user data. Now, shouldn't this data be anonymized? What level of anonymization is good enough? Are there ways that even post anonymization, the company can retrieve the personal data? Maybe they can. So I don't want to go in deeper into examples, because then I have to take some names, but do check out. It is fairly easy to do that. So normal anonymization is not good enough. So then how do I ensure privacy of individuals who are using this particular IoT setup? And there are various ways to do it. For example, from the device security perspective, we can look at asset management, vulnerability management that we already discussed, device security, incident detection, and access management in terms of the device. From the data security perspective, we should have data protection and data security incident detection. This data protection includes all encryption and all those things that we discussed in the PEC slide, right? All of that comes here. Similarly, from an individual privacy protection perspective, we should have information flow management, PII processing permission management. I will have a slide or two more on PII just to highlight, because I think there is another aspect which is different from how we have been discussing other setups in this course. In all the other setups we are discussing in this course, the focus is there is a system which you are trying to protect. In the context of IoT, it is not just the system, it's also the data. The data is sometimes even more important than the system. For example, I have deployed a smart camera, but of course I want to make sure the smart camera remains secure. But the data it collects over years, what happens to that data is also equally important to me, because that data includes, maybe if I have deployed in my home or in our campus also, for example, let's say we have smart cameras, that data has a lot of personal information. For example, cameras deployed in our campus, if somebody uses that camera, they can easily track who is coming when to which class and who is in campus, who is not in campus, where are they in the campus, what are they doing. You can create these temporal charts and predict, okay, based on this, every Tuesday, this faculty goes to take this class in this room. So for sure, he or she will not be in his house, right? So there's a lot of personal data now available. So we have to ensure this personally identifiable information, PII, is processed very carefully as part of the IoT ecosystem, right? Security of the data also is equally important. We also have to do some informed decision making to ensure individuals' privacy, dissociate data management from the device, and also have some sort of privacy breach detection, right? Again, these are potential solutions which can be used to enhance device security, data security, and individual privacy. Again, for each one of them, we can look at machine learning based techniques or AI techniques, right? So this is one example where I would rather say AI, unlike my previous presentation, because in the previous one you're looking at maybe malware detection, maybe intrusion detection and things like that. But here we are also trying to look at decision making without complete information. So in that context, it need not always be just prediction. It need not always be labeling. Sometimes you have to do some sort of reasoning also. And that is where the AI part comes into picture. Another way to look at it is, for IoT device, the device is only as secure as the user. If I have a camera and I am openly sharing its pin, my camera pin is 1234. Then no matter how much security you built in the system, but because I am publicly sharing my camera pin, anybody can access it as long as they know the ID. So we need to create the user awareness. How do we create the user awareness? One way to do that now is, because we have these nice GPT-based models, there should be some sort of regular interaction to create awareness amongst the user. Maybe every week, maybe every 2 weeks, an automated call can go from the manufacturer, hey, you're using our camera, to maintain security, please avoid sharing camera pin. It's very important you don't share it. Or we recently detected that there is this email going around. If you click it, it hacks the camera on your phone. Please avoid clicking any such links. So I think that kind of awareness is another thing which we should be using AI in the context of IoT security in particular, because for all the other systems, anybody who is using a laptop, they already have certain level of technical background. They know how to program, hopefully, right? Or they have that computer literacy. This is not true in IoT security domain. Anybody can buy a smart camera, and a lot of times, for example, in the Indian context, they might not be deploying it. They might be asking a vendor, okay, I'll buy from you, you come and deploy in my house, and you tell me how to use my phone to operate it. So essentially, only having a smartphone is good enough for somebody to start using these IoT devices. So for them to create awareness for such folks, we can use now these AI-based tools, which can really help enhance the experience for each user. And these tools can customize. They can start based on the feedback. For example, if such a call comes to me and I will say, okay, I know this. Don't bother me with these small things. Maybe the AI will update, okay, this person has awareness. Next time only if there is a significant issue, it will call. But for some other user who may or may not have awareness, they can, on the go decide for each user how much to share. So the reasoning part comes into picture, right? Which is why I believe AI has a lot of scope in IoT security and not just the learning component that we have been discussing so far. Coming to the PII, please note, if this personally identifiable information is not managed correctly, it can lead to a lot of inconvenience, sometimes embarrassment, identity theft, fraudulent usages, substantial harm. For those of you who are following the news, in recent time there has been a surge, not from the IoT perspective, but there has been a surge of these calls where somebody would call a person and say, oh, your XYZ friend is with us in police station. And now the government has also started this automated, information sharing on the phones that don't respond to such calls and be careful while responding to such calls. But those folks have certain amount of PII. I am sharing this from my not personal experience, but somebody I know. They were able to tell you have this and this XYZ relative, this date of birth, studies here, lives here, is with us. So they had certain amount of personal information, and exploiting that personal information, they're trying to misguide and cause harm. Can be monetary, can be otherwise also. So we have to be very careful where our information is landing. because it's a connected world, and those actors who are not ethical in nature are easily either misusing it or selling it to folks who are ready to pay and misuse such information. So it's very important that any personally identifiable information is being treated or managed very carefully. And in the context of IoT, for any device that you deploy, there is a significant amount of such PII it generates. So camera is obviously a very direct example because it has the live feed. I can give you an alternate example. We can look at smart meters. Now you would say, what kind of personal information a smart meter may generate? Based on your smart meter's consumption data, it can very easily be predicted. If you live in a 3 BHK house or 2 BHK house, it can very easily be predicted how many rooms AC is working at this point of time, how many rooms AC is not working. Based on that, you can easily predict occupancy. And if you combine this with the behavioral data of individuals, you can actually predict to a very high level of accuracy how many people are there in that house. Now all of a sudden, without a camera, we are able to tell the occupancy of the rooms or the house. So it's very important to treat PII carefully, and that is where the ML part also comes into picture on how to manage this, right? How to ensure it's properly used only for the purpose it is being collected for and not misused as part of the ecosystem, right? So certain general principles, we need to make sure there is encryption for the PII data. There has to be access control and authentication. There must be logging for this. Not only encryption of the data during rest, but also encryption of the data during transit. So if you are communicating this data, we should be encrypting it during communication also. For that matter, even more during communication, because if it's a wireless communication happening, then anybody can sniff. If you have a laptop and a small Wi-Fi antenna and using Wireshark, you can actually sniff any Wi-Fi packet. So unless the packet is encrypted, you can decode any information that is flowing through that packet. Even if it is encrypted, but it is encrypted with lower end encryptions. There are known, just check out on the Google, you can find for let's say 256 and lower bit encryptions. It takes maybe a few hours to break them. So you collect the data, you run a small algorithm, and bingo. Even for encrypted data, you can extract out what is the content of the Wi-Fi packet, right? So you have to make sure that higher order encryption is being used for communication. There should be some notification of data compromise if it happens. The user should know what kind of data has been compromised. A lot of times we hear in the news that XYZ companies' accounts are hacked, and we may also have accounts on those websites and on those pages, but those companies are never approaching us and telling us what was hacked, which is very unethical on their part. They should at least share us so that we can figure out how to mitigate the impact. As a user, it should be our right that if a particular platform has been hacked, if there is a data breach happening, if there is a compromise happening from a data perspective, the person hosting the data, the entity hosting the data must inform us what was the level of breach. But currently I think there is no such, at least in the Indian context. European maybe they have been framing such rules, but I'm not aware of any such current ongoing discussion in terms of a rule or a law. But ideally this should be mandated. There has to be a mandate that a company should share the data compromise with each user by law. Also, there should be an active effort to minimize data retention and to use it only for the mentioned purpose. For example, smart meters. The smart meter data is being collected for billing. That's a primary use case. So what is the point of storing smart meter data more than 2 years ago? And which is why now I think, at least in the Indian context, there is some such laws or such guidelines where they are saying don't store any smart meter data beyond these many months. Because it has no meaning, right? Why to retain? So something similar needs to be designed for each of the use cases that we started discussing, today's discussion with. For every use case, for every device type, suitable such data minimization procedures have to be defined. And that is where the challenge in IoT security comes into picture, because if you see, we had those 20 set of classes: authentication, authorization, encryption, vulnerability management, incident management, so on and so forth, right? Maybe I'll project it again just to set the tone. We have these 20 set of classes. In each of these classes, we have multiple requirements. For example, now we are discussing for PII, we have also discussed for vulnerability management. So each of them can have multiple types of requirements. Maybe, for example, one work we did with NCCS Bangalore, we came up with around 200 plus requirements overall, right? For an IoT device, for a consumer IoT device, from a security perspective. Now, for every device, in every use case, in every ecosystem, some of these have to be mandated. So somebody has to actually define and decide this on the go, because these devices are not constant. It's not that today I have 1,000 type of devices and that is it. Tomorrow the ecosystem changes. Who was wearing a health band 10 years ago? Nobody. Now you look at the fraction of folks wearing a health band, significantly higher. So we must have some notion of such, IoT security requirements for the health band. So it is a very fast evolving world, and then that's where the policymakers need to play a more active role in coming forward and framing these policies from a security perspective. So coming back to the PII part, so from a IoT service provider perspective, they should provide an explanation of what the PII data is being collected for. And analogous to this is, we have these smartphone calendar apps which say, give me access to your photos. It never displays a photo. Why does the calendar need access to photos? So similarly, from an IoT device perspective, what the data is being collected, what is the PII in the data being collected by the device, there should be a clear explanation from the IoT service provider perspective that what it will be used for, right? There should be an explicit consent to collect the data, similar to a smartphone. So at least in smartphone, if you read that initial setup page, it tells you what all will be collected. You can choose to say yes, or you can say no, don't install, or in some cases you can say no, I don't want to share it, but the application still installs. Similar such setup should be there for the IoT devices. They should be explicitly telling you, I'm going to collect this data. Are you okay with this? That awareness will only come if the device installation phase itself is telling you what all data is being collected by the device. There has to be a transparency also what the data is being used for. Will it be used by third parties? If yes, in what context? That information should be shared with the end user, because at the end of the day, this is personal data for a particular user. And ideal world scenario, there should be a way to choose the preference. I should be able to control my preference, how much data I want to share with respect to my PII, how much of it can be used by third party, and if none of it can be used, is the company or the service provider actually not sharing the data further or not, right? That kind of checks and balances have to be there in place. So, which brings me to the last part, which is the AI and ML based solutions for IoT security. Again, because it's a very vast, unlike the other use cases we have been discussing, the framework itself is very vast. There are so many features, right? So across those, now we need to figure out how to apply ML to ensure security. But of course, the traditional ones are there. For example, we have anomaly detection, intrusion detection. These we have been discussing for a while as part of this course. But again, these have to be done for those specific hardware, for those specific softwares deployed on that hardware, and in those specific use cases that we are using this particular IoT device for. Because you change the hardware, you change the software, and the corresponding anomaly, the corresponding intrusion possibilities, or the vulnerabilities available on the device, they change, right? So we have to design these algorithms from a device use case specific perspective. Only then they will have a lot of meaning. It will be very difficult to have one anomaly detection algorithm, ML based algorithm available that works on all kinds of devices. No, highly unlikely. And I think that is where I think Professor Igor also had a session, or I think in CompsNets he had a couple of papers, one on anomaly detection in IoT devices, the other one on intrusion detection, which are very specific in nature, because the system is such that we can't design a more generalized solution. You have to be very specific on within IoT environment what we are talking about, which kind of use case, which kind of device, and correspondingly a possible solution using machine learning. So attack detection and protection again is something where a lot of potential is there using machine learning. There is a lot of work happening at this point of time also, if you check the state of the art. But I personally believe key for IoT security is user awareness. We cannot ensure security in the IoT context, most importantly in the consumer IoT setup, because these are consumer facing devices. No matter how safe you make them, if the consumer is not using them safely, it will open up vulnerabilities, it will open up the device to attacks, right? So we have to make sure there is significant awareness at the user side in terms of security on how to use the device and how to use the associated environment and the framework. Two upcoming technologies that I believe are going to have a lot of value beyond ML in the context of IoT security. One is post-quantum cryptography, because as we discussed in yesterday's session also, once we have readily available those quantum computing units, the current state-of-the-art cryptography will not be enough. It will be very easy to break. Even more so important in the context of IoT, because a lot of IoT devices are limited in their hardware capability. And one of the key computational complexity requirements in hardware is for cryptography. So going back to the example we were discussing in the morning, which is smart cameras, one of the major difference between a smart camera which is 2,000 rupees and a smart camera which is 50,000 rupees is the level of encryption you have available in the 50,000 camera is significantly higher compared to the one which is 2,000. And the encryption at all levels, as we discussed previously, encryption for data at rest stored on the device. For some of the cheaper devices, they have unencrypted data. They're just using one of these cards. I'm forgetting the name for that. These small memory cards we have, right? SD cards, right? So these cameras, a lot of them have built-in slots for SD card. You plug in a 128 GB SD card. It stores just unencrypted video on the camera card itself. So anybody can just take out the card and just extract out all the videos for past 7 days or so, right? So now we have this range of IoT devices, all of which we have to make sure are ready for a post-quantum world. So there's a lot of work happening in that domain, in the domain of PQC or post-quantum cryptography. Second thing that I believe is very important from an IoT perspective is zero trust. Because IoT devices don't exist by themselves. They are part of the ecosystem. If you recall the initial slide, the device connects to maybe an aggregator or a gateway. The gateway connects to the cloud. The cloud connects to the user through an application. So there are multiple nodes, and this is for one device. Maybe the devices also communicate with each other during deployment. So now we have this huge number of nodes as part of this network. And if we follow a zero trust security model, which essentially means we don't trust anybody. Any node sending any communication to us, we will authenticate it. We will make sure it is the correct node or not, verify it, only then process the information. To give you an analogy for zero trust, if you go back to 4G days, the core network for 4G, it has used to have IPsec and all, but not every operator was deploying IPsec. So a lot of communication happening in the core of 4G was unencrypted, right? Or very bare minimum amount of security was there. But now for zero trust, what we are saying is at the access network level itself, starting from the device to all the other nodes in this chain, we will make sure that everything has to be authenticated. For every link, every message that you're sending, it is not that once I authenticate the cloud, then I can keep sending and receiving information from the cloud. No. Zero trust security model means every time the cloud communicates with me, I will make sure there is some reassurance built in into the network that indeed it is a message from the cloud or the core setup, right? So those are some of the areas where I foresee a lot of work happening. But of course, I have not covered the traditional examples, like I have not stressed a lot on anomaly detection in IoT devices or intrusion detection in IoT devices, because Professor Igor has already been focusing on those aspects, right? Not only from the IoT security perspective, but also from other systems. So that is something I think anyway we are going to cover. So my focus was more on to expose other aspects of IoT security, which are equally important. More importantly, from a user awareness and those kind of perspective, because they are equally, if not more important, to ensure IoT security. So that was the last slide from my side.